So far in the unit on area within the larger series on measurement, we've been looking at how to calculate the area of basic shapes. In reality, however, shapes are rarely regular and we need to find the area of a number of basic shapes to find the total area. In this video, we're going to have a quick revision of area. We're going to look at the converting units of area chart, what a composite shape is, and we're going to find the area of composite shapes. This is a reminder of what area is and the units used to calculate area. You'll notice that there are 24 squares inside the rectangle example provided. As the sides are labelled in metres, we say that the area of this rectangle is 24 metres squared, but we don't count the squares to find the area. In this case, we multiply the length by the width, which is the formula for finding the area of a rectangle. I've included this just for anyone who is watching and is working out problems where they need to convert between units of area. This was covered in more detail in the area units and areas of squares, rectangles, and triangles videos. Composite shapes are made up of more than one basic shape. Area of composite shapes can be found by adding or subtracting the area of more basic shapes. The hardest part is identifying the basic shapes. It's important to note that the layout of the relevant mathematical working needs to make sense so that the reader or the person marking your work can understand each step. Let's look at finding the area of some composite shapes. The most important part is being able to identify the shape. In this shape here, it looks like we have a square and a triangle. So the area of this composite shape is going to be the area of the square plus the area of the triangle. Let's look at the example with some numbers. So we've got the example here with the numbers. When we write the formula, we've got the area of a square, which is the length squared, plus the area of a triangle, which is half the base times the height. We're given the area of the square, and that's 2 meters by 2 meters. The height of the triangle is 2 meters, and the base of the triangle is going to be 1 meter plus 2 meters plus 1 meter. So we can place that into our formula, and we can calculate and evaluate. So you can follow the steps, and we get the area of this composite shape is 8 meters squared. Here we have another composite shape. It looks like the shape has maybe a semicircle on each end and a rectangle in the middle. So it looks like we've got the rectangle in the middle and we've got two semicircles on the outside. So the area in this case, we don't need to calculate two semicircles. We can just calculate the area because we know the radius given on those semicircles is the same as an entire circle. So we're going to calculate the area of a rectangle plus the area of a circle. So we write the formula for the area of a rectangle and the area of a circle. Now we're going to write our diagram with some numbers in it. And we can rewrite our formula and evaluate. So you can follow the steps through. And we get the area of this composite shape is 60.57 meters squared. Here we're going to find the area of the shaded region. It looks like we've got two rectangles, so there's a rectangle on the outside highlighted in red and a rectangle on the inside highlighted in yellow. The area of the shaded region is going to be the area of the outside rectangle less or take away the area of the inside rectangle. So we can write it like that. That's going to be length times width, take the length times width of the inside rectangle. Here we have the diagram with some numbers on it. So we can write them into our formulas. We're going to get 39 take 24, and we end up with 15 meters squared for the shaded region. Here we're going to find another shaded region. What we have here is an ellipse and a circle, and we're given a number of possible measurements in there. So we write our formula. It's going to be the area of the ellipse, take away the area of the circle on the inside. So we write our formulas. The area of the ellipse is pi AB, take pi r squared, the area of a circle. Here we've got the example with some numbers. You'll notice that it doesn't look like, in first instance, it doesn't look like we're given A from the above diagram. But because the it's a circle, the 3 centimeters is radius, and that's also going to be A for the ellipse. So we can write those numbers into our formula. So we have pi times 3, which is the radius of the circle, which is also A in the example above for the ellipse. And then B for the ellipse is going to be the radius of the circle plus the extra 5 centimeters. Take away pi times radius 3 squared. So when we evaluate, and we get 75.4, take 28.27. We end up with the area for this shaded area is 103.67 centimeters squared. That's it for composite shapes. In the next video, we'll look at the area of irregular shapes using simple shapes. And then we'll look at the area of irregular shapes using the Simpson's rule. Then we'll move on to volume and capacity. Thank you.